Hi everyone, welcome to this video on Spring Security, a topic that many developers find challenging. But here is the truth. Spring Security is not hard. What makes it seem difficult is jumping straight into coding without first understanding the foundational concepts of security. To truly grasp Spring Security and implement it effectively without unnecessary struggle, I would like to advise you and recommend three things. Do these three things and Spring Security will become easy. Number one, do not jump straight into the code. Take a moment to understand why security is important and how authentication and authorization work. Number two, understand the basic concepts first. Learn about things like filters, authentication providers, security contexts, and how Spring Securities manages requests. Number three, then start implementing these concepts practically. Once you have a solid understanding, writing secure application will become much easier. By following this approach, you will build a strong foundation and avoid common pitfalls. So stay focused, take notes, and let's run Spring Security together. I would also like to encourage you, do not forget to subscribe and hit the bell icon so that you can never miss an update. Let's get started. So, Spring Security. I would like to tell you that every application that you need to design, security should be number one priority. Security is not just an option, but a thing that should be in your mind even during the design phase. So I want us to know why secure your application. The number one reason why we need to secure your application is data confidentiality. Securing applications ensures sensitive data is accessible only to authorized users. Encryption during data transit and storage prevents unauthorized access. Number two is business continuity. Protecting against cyber attacks like DDoS, which means distributed denial of service, minimizes downtime and ensures seamless operation, safeguarding time, money, and reputation. I want to give you a very good example where some hackers may fire millions of requests to your website to bring your website down. This will make the authentic and genuine user to be denied the services because your website is down. Such kind of threats, we should mitigate them. Number three is privacy protection. Securing user data such as financial or health details prevents breaches that could cause identity theft, fraud, or harm. Encryption and restricted access are key. Imagine a scenario whereby the user information like PIN, password are stored as raw data without being hashed or encrypted. This is a bad practice. This is exposing user information to security threats. Number three is trust. User trusts secure application and breaches can erode this trust. Robust protocols like 2FA, which stands for two-factor authentication, and SSL, secure socket layer, reinforces the confidence and credibility. The other reason why we secure our application is integrity. Application security ensures that data remains unaltered, preventing fraud or operational issues such as tampering with transaction record. The other reason is compliance. Government and regulatory body have established strict rules and standards to protect users from cyber attack, and meeting avoids fines and penalties while enabling secure global operation. Remember, in a security breach, is very expensive to a company because the governments and other compliance body uh, who are regulating things like cybersecurity, they impose heavy fines on the companies, and this can lead to massive loss of income. Therefore, Spring Security is very, very important for the compliance. So let us now go to key security principles and best practices. Key security principles and best practices. Number one, what is authentication? Authentication is verifying who you are. It is like showing your ID card to prove your identity. Example is when you log into a website using your username and password, you are proving to the system that you are who you claim to be. If I claim that I am Albert, I need to verify that I am whom I claim to be. That is authentication. The other key term is authorization. Authorization is the process of determining what you are allowed to do after your identity is confirmed. It is like a security guard checking your access badge to see if you can enter a restricted area. Example, after logging in, the system checks if you have permissions to view or edit certain files or access specific feature. That is authorization. Security by design. This is one of the security best practices. Incorporate security from the start of system development using secure coding practices, threat modeling, and rigorous testing. Remember, security is not an option. It is a must. You must develop secure application, most especially applications that deals with financial or money. They must be secured. So security is a must. Least privilege. Grant user or systems the minimum access needed to perform their tasks, reducing the risk of unauthorized actions or breaches. Assume a scenario whereby a certain user wants to log in into the system and view the list of registered user. So this user needs to be given only the read-only permission. But what will happen when this user is given other privileges like delete, update? This user can perform some task which he or she was not supposed to do. Therefore, the principle of least privilege is a key. The other one is confidentiality. Ensure that sensitive information is accessible only to authorized individuals. Techniques like encryption, secure passwords, and access controls enforce confidentiality. The other one is input validation. Input validation ensures that the data provided by users or systems is clean, correct, and secure. This is crucial to prevent attacks like SQL injection or cross-site scripting. So we shall see all these concepts practically. A very good example is validating your input field. Like for example, a hacker may write some malicious script on the input field. So whatever the input allows should be sanitized. It should be sanitized. Validate inputs on both client and server side to ensure they meet expected format, e.g. numbers, dates, email addresses. Imagine a scenario whereby the name of a person is all special character. This can lead to SQL injection and cross-site scripting. A login form that ensures the username contains only alphanumeric character and a password meets complexity requirements. The other key security principle and best practice is auditing and logging. Auditing and logging track user and system activity for monitoring, troubleshooting, and forensic purposes. These records are vital for detecting anomalies and providing evidence after a security incident. This is how it works. Log significant events such as login attempts, data access, or configuration changes with timestamps and user ID. Ensure logs are protected from tampering. So basically, an example is when you log into the system, we need to track every activity that you do with the system right away from login, viewing financial information, anything that you do with the system need to be tracked, and that is auditing. Regular update and patch management. This is the best practice. You need to adhere to regular update and patch management. Regular updates and patch management addresses vulnerabilities in software, reducing the risk of exploitation. Developers release patches to fix security flaws, improve functionality, or enhance performance. Remember, the dependencies that you will use or the libraries that you will use in your application, they should be updated. Some of the old dependency may have some security vulnerability. Regularly check for updates from vendors and apply them promptly, especially critical patches. So I want to give you a very good example is there was a vulnerability that was detected in 2021, Log4j vulnerability. That vulnerability was discovered in December 2021. It allowed attackers to take control of system remotely by exploiting how Log4j processes certain logs messages. This issue was quickly addressed by releasing patched version of Log4j. So it was addressed by Log4j version 2.17.1. So you see that this was a known vulnerability and it was fixed by a new update, a new release, a new patch. So it is good to ensure that all your libraries are up to date. So I want us to go to why Spring Security. So there are so many ways of implementing security in your application. You can implement everything from scratch, but why should we not implement everything from scratch? Why do we need Spring Security? Why? Spring Security offers out-of-the-box support for authentication and authorization. This means that you don't have to implement everything from scratch. Spring Security provides support for this, as well as protection against common vulnerabilities like CSRF, session fixation, clickjacking. Allow protection against the most common threats, e.g. XSS, clickjacking. We are going to look at how we can protect ourselves against all these attacks. Modern security standard support. Spring Security support modern security standard. It supports modern security standards and protocols like OAuth2, Open Authentication, uh, SAMR or Security Assertion Markup Language, OpenID Connect, LDAP. Also, Spring Security has got a large community and support, meaning that whenever you encounter some issues, you have a large community and a large support. Also, Spring Security team regularly updates libraries. So there are regular updates to Spring Security. Like for example, you'll find that moving from from one version of Spring Security to another, there is regular updates. Important Spring Security terms. Before we begin, it is good to understand several important Spring Security terms. So the first term is principal. You will encounter this term many times. So what is principal? Principal represents the currently logged in user. Your user details like username, email become your principal, your identity within the application. The other term is authentication object. Authentication object. The authentication object is the tool the system uses to check if you are who you say you are. It is like a bouncer at the door checking your ID to make sure you are the person on the guest list. When you try to log into an app, the authentication object is the process that checks your password or fingerprints to make sure it matches the principal. Basically, we have said the principal is your identity. Authorities. Authorities are the permissions or rights given to a user to perform certain actions in a system. Think of them as keys or passes that allows you to do specific things within an app or website. A very good example is after a person logs in, this person has got the permission to edit the list of user, permission to disable user, permission to delete, permission to create, and so on. Then there are filters and filter chain. Filters and filter chain. Very important. Please pay attention to this. Please. In Spring Security, filters are like checkpoints in a security system. They check incoming requests, perform certain actions like verifying a login or checking permissions, and decide whether to allow or block the request. So what are filters? A filter is a piece of code that intercepts or inspects requests, e.g. HTTP requests, before they reach your application's core logic. It can perform tasks like checking if a user is logged in, verifying if the user has the right permissions to access a certain page, modifying requests or responses, e.g. adding headers. So what is a filter chain? A filter chain is just a sequence of filters. Sequence of filters. When a request comes in, it goes through each filters in the chain one by one until either one all filters passes and the request reaches the application, or one of the filters blocks the request, e.g. unauthorized access, incorrect input. So that is why we need filters. Very, very important. Let us look at real life system. Check for invalid character in a username. Imagine you have an online registration form where users create account. You want to make sure that username does not contain certain characters like at, hash, or percentage sign. Here is how it works. The user submits a registration form with a username. A filter intercepts the request before it reaches the backend. The filter checks if the username contains the forbidden characters. If it does, the filter rejects the request and sends an error message. If the username is valid, the filter allows the request to pass through to the backend. Request comes in. For example, if we have a series of filters and that has been successful, maybe filter one is checking for authentication. It checks if user is logged in. If not, it blocks the request. If yes, it passes the request to the next filter using chain.doFilter. This is how you pass. Chain.doFilter is a method in Spring Security that passes request to the next filter. Filter 2 maybe is for validation. Checks if the username contains forbidden characters. If it finds a problem, it blocks the request. Otherwise, it passes it to the next filter. The request reaches the application if all filters allow it. In Spring Securities, filters and filter chains are used for authentication, authorization, among others. Now, I want us to look at how Spring Security works internally. How Spring Security works internally. Allow me to visit this diagram to explain how Spring Security works internally. Basically, what happens is that once a request, maybe a login request, goes through a series of filter chain, and one of the filter chain is authentication filter. Basically, we have said the purpose of a filter chain is to intercept requests and maybe modify the request and response, do some validation. Basically, one example of filter is authentication filter. What the authentication filter does is it intercept the request, extract the credentials like username and password, creates an authentication object. So an example of authentication filter is username password authentication filter. So it creates an authentication object. So authentication object contains user's credentials as well as a flag whether a user is authenticated or not. Initially, the authenticated flag will be false. The authentication filter then calls the authenticate method inside the authentication manager and passes the authentication object. So the authentication manager delegates authentication to one or more authentication provider, and in this case we have the DAO authentication provider. So what is the purpose of this authentication provider? This authentication provider calls road user by username from user details service to road the user details like username, password, roles. It then calls the matches to check whether the provided password matches what is in the database. Remember, the passwords are stored in the database as hash, and a hash is a one way, meaning once a password is encrypted, it cannot be decrypted. So password encoder is the one that provide matches and encode method. So uh, once these password matches, the authentication provider will update the authentication object status to authenticated. So after the authentication object is updated, the authentication filter will then store the authentication object inside our security context. Remember, our now authentication object contains the credentials like username, password, roles, and a flag indicating that the user is authenticated. And this will be valid during the duration of the request. So the request then goes back to the filter chain, then to the application controller. So the application controller processes the request and pass the response back to the filter chain, where that response can be intercepted. Maybe some security headers may be added, and then the result is given back to the user. So basically, that is how Spring Security works internally. That is how Spring Security works internally. That was just a high level, and maybe I want to go through this diagram once more. Basically, what I am saying is that once a request is received, maybe a username makes a request via a web browser or client application. This request goes through a series of filter chain. The filter chain intercept this request and do things like validation, verification, extraction of headers, etc. So the request will go through authentication filter. This is a filter that extracts user details and creates an authentication object. So the contents of authentication objects are things like username, password, is user authenticated. So I have said that this authenticated flag initially is false. So Upon creating that authentication object, the authentication filter calls the authenticate method from authentication manager and passes the authentication object. The authentication manager then delegates authentication to one or more authentication provider. In this case, a common authentication provider in Spring Security is DAO authentication provider. So this DAO authentication provider actually does the authentication. How does it do it? It calls road user by username from user details service, and this will return user information like username, password, and roles. It then calls the method matches from password encoder to check whether the provided password matches whatever is in the database. So basically, I have told you that this hashing is a one way. It's a one way. Some of you may ask, how does it does that? Does it first of all decrypt the password and compares the decrypted password with the raw password? Not, not at all, because we have said that hashing is a one way. So what it does is it takes the raw password from the user input, then hashes that password, and then compares the two hashes using the matches. If the two are the same, now the authentication is successful. It updates the authentication objects, and after updating the authentication object, the authentication filter then passes the updated authentication object to the security context, where it will be stored for the duration of the request. So the request then goes back to the filter chain and then to the application controller. So the application controller now calls the business logic, processes the data, and return the request back to the user. That request may go through a filter chain for validation, verification, or header extraction. So friends, that is how Spring Security works internally. So I want to stop at that point. Thank you so much. I really appreciate. Some of these videos are taking too much time from me. So I would encourage, I want to share my knowledge with you. So please hit the subscribe button and the bell icon so that you don't miss important update from me. Bye. See you in the next video.